All right, try a few problems here. Why don't you give this one a shot? Right now, I would not expect you to know how to analytically do this, so this would be kind of like grab your calculator, use the graph or the table to figure out the limit of this as x goes to 2. It's worth trying to see if direct substitution works. If you plug 2 in on top, we get 0. If we plug 2 in the bottom, we get 0. 0 divided by 0 is indeterminate, so direct substitution does not work. So I'll give you a minute to try to figure out what a good approximation for that limit will be. All right, so typed it in. Have a look here. That's what the graph looks like. We want to know at 2. So what I could do is I could hit trace. And I want to know right now x is 0. If I put x at 2, or close to, looks like my y value is 2.82 maybe, 2.81 something. Okay, so that's one way of doing it, hitting trace. That's the only way I ever use trace. Well, it's the only way I can think of that we ever use trace. Just trace and it'll give you an approximation of the limit. A better way is to go to the table. We're going to start at, let's see, x is approaching 2, so I'll start it at 2, and going up by 0.01 is good. Go to table, and we can see that just to the left of 2 is 2.82, just to the right of 2 is 2.83, so 2.82, 2.83, somewhere in there, we'll say it's about 2.82. So it's not the ideal way of finding the limit. If you don't have an analytical way of doing it, then the graph and table technique will always give you an idea. So, could we have done this analytically? The answer is yes, otherwise I probably wouldn't have asked it. What if I had, we remember x squared minus 4, we factored that yesterday. What's x squared minus 4 factored to be? X plus 2, x minus 2. Very good. Okay, so what would x minus 2 factor to be if we consider that a perfect square or a difference of squares? So what do I have to take? The square root of x squared gives me the x's. The square root of 4 gives me the 2's. What do you suppose would go in the first two spots here? Square root of x. Because the square root of x squared gives you x. What's going to go in the other two spots? What's the square root of? Square root of 2. So square root of 2, you were dividing by 2, I think, yeah. So square root of x plus 2, square root of x minus 2. You can actually factor x minus 2 as a difference of squares. It's the square root of x plus 2, square root of x minus 2. Okay, so knowing that, square root of x plus 2, square root of x minus 2, all over square root of x minus square root of 2. Oops, square roots there. What do you suppose we can do? Yeah, cancel it out, cross it off, divide them off. Those are gone, so I'm left with the square root of x plus the square root of 2. Okay, we algebraically manipulated it. Now what do I do? We're one step away. If I asked you what's the limit of this as x goes to 2, how do you find it? Plug in 2. It's the last thing we have to do. X is going to 2, so it's the square root of 2 plus the square root of 2, which is 2, square root of 2. Now I wonder what 2 times the square root of 2 is. 2 square root of 2 is our 2.82, 2.83. Okay, so that's our exact answer. And that's our approximate answer. Okay, so that's one way to analytically do it. Another way that actually may have more applications, if I'm still trying to find the limit here as x goes to 2, I can multiply the top and bottom by the conjugate. Now we've done conjugates this year. What it is when you change the operation in the middle, so it's now going to multiply by the square root of x plus the square root of 2, square root of x plus the square root of 2. I'm multiplying by the conjugate of the bottom. Now if I distribute that, FOIL it, square root of x times the square root of x is x plus square root of 2 square root of x minus square root of 2 square root of x. And what's the square root of 2 times the square root of 2? 2. So minus 2. And then the top I'm going to leave it. I'm not going to FOIL it because when I combine the bottom I'm just going to be left with x minus 2. And now we can just divide those out and we have what we had before. So we get 2 square root of 2. So it's a second way, I guess a third way of finding the limit. This is the second way analytically doing it, just multiplying by the conjugate of the bottom. All right, so one question, very teachable moment. Got to show you a couple different things. Let's try another one. We will call it number 2. Any thoughts? Synthetic division. Oh, man, it's been a while. But yeah, that's what you got to do. So we could try factoring the top. We could factor by groupings. I could take out an x squared and be left with x minus 5. Like x squared times x minus 5, but then I could take a 1 out and I'm left with 11x minus 50. You cannot factor this by grouping. But you could do polynomial or synthetic division. I like the synthetic quite a bit better. So 3 out front, coefficients in place, and we should get 0 right here if we did it right, if it factors. I'll give you a second to try. See if you can remember that stuff. Remember, we bring down the 1, then multiply, and then add. Multiply and add.
Why is that negative?
Because you put the 0 out front. Whatever makes that 0 is what you go out front. So that's why it's positive 3. All right, so it divides off evenly, so we get 0. So that means x minus 3 is a factor of it. Well, that's good news. So the bottom is still x minus 3. What's the top going to be right now? What times what? X minus 3 times what?
X squared minus 2x plus 5.
Very good. X squared minus 2x plus 5. Those are the x squareds. Okay, it's kind of like saying if I have 8 divided by 2 and get 4, I could write 8 as a factor of just 2 times 4. So if I divide that and get 4, then I can go 2 times 4 is 8. So we divided that by x minus 3, and I got this. So x minus 3 times this must equal that whole thing up above. Okay, so then the x minus 3's, I'll let you finish the problem. All right, so that's another technique. If you can do polynomial division, which is just a way of factoring. We factored the top into this, and then you can use the cancellation method. Simplifies to be this, and then you can plug 3 in using direct substitution. All right, a couple more. Give that a shot. All right, I gave you 25 minutes to think about this. Did anyone come up with a solution? Claire, what do you got? So she just plugged in -1 right away. So square root of -1 plus 4 over -1, which is the square root of 3 over -1, which is negative square root of 3, whatever that is. Okay, so don't be doing all a bunch of algebra if you can use direct substitution if possible. So you should try that. If it doesn't work, then you have to move on to another technique. All right, last one, then I'll answer some questions if you have them in your assignment. Number 4. There isn't anything to do analytically here. See if you can figure out what the limit is as x goes to 2. All right, so before I make a graph here, can somebody tell me what the domain of this function is? All reals except for what? Except for 2. Very good. So at 2, what do we have? An asymptote, vertical asymptote. So it kind of looks like this, and this one kind of goes like that. All right, so what is the limit as x goes to 2? Well, from the right, what's it going to? Infinity, very good. And from the left, it's going to negative infinity. So since they are not converging to the same finite number, then you would say does not exist. Even if it was like this, they both would be going to infinity. Technically, the limit would not exist here either. Like if it was that, I think that's what that graph would look like. You're right, does not exist. A better answer probably is that the limit is infinity. So from the left and the right, it goes to infinity here. But technically, a limit has to be a finite number.